Good afternoon. Wow. I am apparently mic'd. For those of you who don't know me, my name is Michael Bernstein. I'm an assistant professor here in the computer science department in the Human-Computer Interaction Group. And on behalf of the Human-Computer Interaction Group and the larger interaction design community on campus, we're very excited to welcome you to the seminar on people, computers, and design for the 2017-2018 school year. So, many of you are old hat at this, many of you are new. I'm going to do just a couple minutes of housekeeping and explanation of what this is, and then we're going to actually get started with our exciting speakers today. So this is a seminar series, which means that it consists of speakers who are not the faculty. We invite some of the brightest minds in interaction, people, computers, technology, design, to this seminar, which we run weekly in this slot, Fridays, all 3 quarters of the academic year. And it is always open to the community, open to students, open to the public. So please join us whenever you're interested in it. The seminar has been running nigh on, I think, 30 years at this point. So really, really impressive history of major accomplishments happening here. As your MC, I will essentially be introducing each week's speaker. Some of you are enrolled in a course, CS 547, in order to get a unit of credit for attending this lecture series. If you are doing so, the rules are pretty simple. Come to the talks. That's basically the entire syllabus. So there's a lot more detail at cs547.stanford.edu. Basically what you need to do is each week go to the website. There's a link to a Google form where you log your attendance. You can check through that site what we have a record of. Geza, who's the CA for the course, has whipped that up very kindly. At the end of the quarter, we will just essentially check that you've attended all of the lectures. So you need to attend 8 of the 10 in person. You can watch 2 remotely unless you're an SCPD student, in which case, because you're SCPD, you should probably be watching them all remotely. That's basically all that we need to check up on. Most of the details, as I said, are on this website. Are there any questions at a high level about how the course works or the seminar series works before we dive in? Okay, that was easy. So yes, 1 unit, register your attendance, and you're good. Please, we intend this to be an interactive seminar, so please be the interactive part. Ask questions, discuss, debate. You know, these folks are here to share their visions with us, but also looking to learn from us in conversation with us. So I will jump in. So this week we are extremely excited to welcome, I believe, all 4 members of the LLVR community, but 2 in particular are speaking, Evelyn Eastmond and Hart. So Evelyn, I believe, has an MFA and is a faculty member at RISD, which you may know is essentially one of the top design and art schools in anywhere. And she was telling us at lunch that she has a fascinating background that started out working on really software-based systems and then decided to go get some real depth on the art side of the equation and now really brings them together. Vi has, I believe she describes herself as a mathematician and philosopher, is what I got, and has done a lot of work at the sort of the intersection or the union, or I'm not even sure what I would describe it, somewhere in the general vicinity of many different topics that think about communicating abstract concepts to large publics. She's very interested in getting to the core of a complex idea and helping other people understand that, which is something that I really, really resonate with and respect quite a lot because it's a very difficult skill. Vi, if you go search for her name, has all sorts of really, really fascinating and fun videos that are explaining all sorts of concepts, got all sorts of YouTube views. She's kind of a big deal, so is Evelyn. We're excited to welcome both of them to Stanford today, where they're going to be talking a lot about the year of the body and where they're thinking about augmented reality and virtual reality. So over to you.
Hi, I'm Hart, and I'll just give a quick intro while Evelyn gets mic'd up. So we are part of LLVR. We're a research group that does virtual, augmented reality, or XR, MR, whatever you want to call it. trying to get at what the future of embodied knowledge is in embodied computing, when we can finally capture the knowledge that includes the things our bodies know, things that often get called intuition. And then the other two members of our team are also here, Evelyn, Andrea, and Andrea Hoxley and M. Eifler. And so all four of us will be around later. And so first, because this is a class, can I just get a show of hands for how many people are students? Lots of students. All right, can we get hands for non-students? How many people are both students and non-students? Yes, intersections. Okay, cool. And because this is a class and we have so many people who are students here, feel free to raise your hand and ask questions and be, participatory. Welcome to your first week back at school. And yeah, let's intro ourselves. So that's us. That's me. I do some stuff on the internet sometimes. That's what most people recognize me from. And then other internet work that our research group has done in the past 4 years, including things like Parabola to polygons. And all right, Evelyn, are you mic'd up and ready?
I think so. Oh, yeah. And as Michael said, my background is in computer science and programming language design, and then I made the switch over to the fine arts. And this is a piece I made kind of in the middle of that journey where this is an artwork, a triptych, where the top screens those are computer screens and the bottoms are paintings, and I match them in color. So it just kind of represents where my career has gone.
All right. So a quick intro to stuff our research group has done. We've been working together for almost 4 years now, and we've really gone through a lot of topic changes since then, since VR and AR has changed so much in the past 4 years. So recently we had a 360 video in the New York Times, I guess earlier this month, showing hyperbolic space in VR. So virtual reality computers, they don't know what space is like. They don't know anything about reality. So if we program them to do hyperbolic space instead of Euclidean space, the computer has no problem with that. It takes a little bit of 4-dimensional projections and stuff, but you can do it. So that's part of our more recent work, hyperbolic stuff, which was also covered by Nature. See, we have cred. But we started with 360 film and camera and trying to understand how 360 3D video would even work mathematically. So that was kind of our start was in film, kind of coming from my YouTube and film background. So those are some of our earlier cameras that M made with like hot glue and foam core and managed to stitch together all the footage. And then we started to transition into 3D stuff, so both video, spherical video, and then these 3D animated characters. This is running on the web in WebVR with both 3D and spherical video components. Then we started to get more 3D and spatial. This is like a puzzle game where you kind of move through the world by crouching and standing on moving platforms. We added more senses to the mix. This is a multisensory peachy ring experience where you eat a peachy ring while looking at a virtual world where you're surrounded by peachy rings. So, and also going back and forth between physical objects, the physical world, and the virtual world to really understand the strengths of each, and always remember that even when you have a headset on, you're still a person, you're still in reality, you still have a body. And so it's not just about your eyes and what you're seeing, but what you're doing matters, and where we have all these intuitions about what happens when we walk forward. We should move forward in space. We learned that, when I move, this thing happens where I see things a particular different way as I see kind of the 3D real world graphics. This in this case is 4-dimensional. It's an arrangement of monkeys that started as a physical sculpture done with Henry Segerman and Will Segerman. And then we brought that, once the technology was far enough along, into virtual reality. So yeah, this was several years ago. And now we're moving more and more towards the back and forth between physical reality and headsets to try and bring together what we can understand using both.
So this going back and forth has been interesting for me in the arts. Like I mentioned, first I started in computer science, moved to the fine arts and physical materials. And at the time, I think I made the transition because there was something missing from the way I was interacting with the computer and the things I could make and digest or consume with a computer. There was something in my body that just wasn't sitting right. There was some unresolved stuff I didn't understand. There was a lot of pain. There was a lot of pent-up stuff in my body that I knew I needed to work with in a more embodied way. And I think that's why I initially made the transition over to the fine arts and left the screen for a while. But then that had its own challenges too, where it turns out if you want to be a fine artist and you want to be making imagery the way painters do, there's a little bit of imagination involved. You do have to kind of go back into your brain, into your mind, into your past, and think about what kind of imagery you want to work with. I was having trouble doing that then. There was no amount of sketching and no amount of looking at other artists that was really helping me get there. Until I went to an artist residency earlier this year at the Banff Center for Arts and Creativity, I think it's called, in Canada. And I got this desire, this kind of drive to bake some cakes. I had to bake these cakes. So I baked these cakes that I didn't frost or anything. They needed to be raw. They needed to be kind of messy. And then I wanted to work with them, but they were really crumbly. I couldn't, I wanted to kind of rearrange them and do things with them, but they were really frail because they were actual cakes and were starting to dry and crumble. So I took a 3D scan. That's when the first time kind of the digital started coming back to me. It came back to me and it started helping me on my journey. So I did a 3D scan of the cakes, and once I had that 3D scan, I could go start playing around with the cakes a little more like I wanted to. I just, with my cell phone, I made a little app and I got a little marker, and the marker, if the camera on the cell phone looked at the marker, it would make that stack of cakes appear. And so it meant I was really mobile, really easy. I could just go walk around in the world and put the marker down, look through my cell phone, and there was my cakes. In this case, I think they come from some flashbacks, some memories. So I felt like I was taking my memories with me to different places and putting them out there. So like the carpet and doing things that maybe aren't physically possible, you know, on this like edge of a plant or something. And all of a sudden I had imagery, you know. I was trying to be a painter. I was trying to be a fine artist. And the digital kind of started giving me this power again, where I could make imagery. And these pictures I started, this is a quick recent experiment where I took one of these pictures and made a print on some fine art paper, which is why you see that texture. And I'm starting to double the images on a larger piece of paper to see and think about topics of flashbacks and the way that they come over and over and over again, just see how that feels. Another image from my flashbacks is this drumstick ice cream that I also 3D scanned and then put on a marker too, which I hid here under white. And I just wanted to see what it would feel like to make still lifes with the ice cream. And so here are some vegetables, and these are real vegetables and real fruit, but a digital ice cream. And again, this is just with my cell phone, a quick experiment one day, just seeing what it feels like. And then I come up with some photos. And these haven't made it back out into the real world yet, but maybe I'd turn these into prints or paintings, not sure. But yeah, working this way, just kind of, the imagery just started coming, which was really nice.
Yeah. So one of the most immediate compelling things people often do in virtual reality, often like the first demo people do or try, will be a simple painting app. Because it feels very intuitive to people when they can move and then see this amazing trace of how their hand is moving. And there's something very magical about that. Actually, can I get a show of hands? Who has done VR of some sort or worn a VR headset? Okay, this is great. Wow, great. That is more people than I've ever seen in an audience. Okay, that's awesome. Who has tried a painting app or something like Tilt Brush? Okay. Oh, this is so cool. Okay, this is wonderful. I'm so happy to have an audience where like so many of you know what I'm talking about, like the magic of just having your body's motion be captured in space, and like it's so easy to just like doodle and draw. And I love doodling. I didn't think that the work in VR would start to come back to the magic of doodling and just the way that your body can kind of just do these things, and maybe you can just kind of get into it and you're not even necessarily thinking about it in the way we're used to thinking. But yeah, getting that body knowledge back in there. Okay, so once we got hand controllers working with spatial stuff, and I guess this is like 2 years ago, we made a quick kind of painting drawing app. And this is when we started to really understand how profound it is that virtual reality can capture the movements of the body, and it's not about what you see and that's the fun part, that you can see this other world, but the fact that now computation can capture your body, that's really what was exciting to us. So this is, I guess, a cover of Seymour Papert's Mindstorms, or one of the editions of Mindstorms, and that's a turtle computer that can be programmed in Logo. Can I get a show of hands who's familiar with Logo and turtles and stuff? Oh, you're the best. All right, so we'll just give a quick intro of that. That Logo is a language that basically you can program this line-drawing robot kind of from its own perspective. And in Mindstorms, it's very much emphasized that children can find this intuitive to learn how to program because they can kind of embody the turtle, that you can walk forward a certain number of steps and then turn right, and see this from the kind of perspective of the program. And trying to get your brain in the space of seeing programming from the perspective of the program itself is actually a really useful tool, and I think we could use more of that in programming. So we were starting to get towards these embodied metaphor stuffs, and then Alan Kay came by, and he's like, let me tell you about this thing we did back in Smalltalk and Squeak with teaching children how to program, where back in the, when was this? Do you remember? 70s? Somewhere in the 70s, where to get children to understand acceleration and how you might program acceleration in a video game, he took it out into the real world. Here he is dropping a ball off of a roof of a school, and as it falls, they're filming it. And so they see it fall. How does it look like it's falling? I don't know. Let's look at the video frames. And through the video frames, we can kind of get this visualization of acceleration, because the video frame happens at an even amount of time, but the ball does not move linearly. And then they would take this back into a program, like measure this, get real-world acceleration out of this. So he was telling me about this and trying to like push me towards education stuff. And this is an example of a Squeak program that uses this Squeak eToys program that uses kind of the acceleration gotten from that experiment. And I thought, well, with VR, we can do that in real time now. You don't have to drop and film and look at some frames later once you print them out. We can drop an object, track it in the real world, and get those frames to just appear in front of us of where it's been at every moment. And then we can measure that in real time. We can get a graph of that in real time. And what I expected was to kind of get a copy of that experiment, but in real time with the frames in front of us, and maybe we could even program with our hands in front of us. But what I actually learned once I kind of quickly prototyped this system, and I'm just going to kind of play.
So I wanted to show just a
demo. Can you turn off the sound?
Real virtual physics.
Oh, we can turn off the sound. Perfect. Because I'm just going to talk over this. So when I got in the system and started playing with it, what I realized is it's really not about the VR part. What's so magical about this is that when I move my body, I know what I'm doing. And then I can see an abstraction, a graph of this, in this case just the Y position. I can get an abstraction of that I don't have to connect to something else I need to look at. It's intuitive to me when I can feel it and connect what I already know to what I'm seeing, instead of having to like synthesize two different things, like a video of a thing and a graph abstraction of the thing. So here, yeah, we have acceleration graphs, speed graphs, and then you can kind of match up the derivatives. At some point, we'll see, like how do you get things to be fast? You'd think a thing moves fast if you shake it really fast, and then when you see the graph, you realize actually it's not moving at all at either end of your shake, and then you can move your arm in circles. And this experience really made me realize everything I had been thinking about VR was kind of not on the right track. It was all about this knowledge we have about where our bodies are. That's just instant and intuitive. Okay, so.
Quick question on this.
Yes?
Do you think it would have been equally compelling if you had no display on and just the trackers?
I don't know about equally, but certainly partly. This was a big moment for me of like, the headset is not everything. It's not really about the headset. It's about this spatially tracked stuff. And now, even without the headset, yeah, you could do a compelling thing where you're moving your body and forget about the headset. So partly. OK, so that was that. So I started taking like the art body side more seriously and was learning from Evelyn like what are artistic practices, including this idea of making 50 of something, which was an art prompt from.
Well, I don't know. I remember early on in art school, the kind of prompts for trying to get students to think out of the box, which is one of the really hard things with new art students, is just how to get past kind of the obvious or the first thing. And so a lot of art teachers will kind of just try to exhaust the students, until you're basically drop dead. And so they'll say like they won't say like to draw the bowl of fruit. They'll say draw the bowl of fruit 25 times, right? So that in the first 5, you draw what you see, and the next 5, you might draw something else, and then by the 15th, you're just drawing something. And that's when the real juices flow. And so I shared that with the team.
Yeah, and that's a great tool that I had never learned was a thing. And so first, Evelyn started doing this with, I'm going to make 50 beds in VR, just really quick in real time, making them in a VR kind of sketching tool, making all these beds. And I'm looking at this, and as the beds got more and more kind of out of the normal space of what you think of as a bed, I'm like, I want to do this, but with embodied knowledge and conceptual understanding. And so if I can, I don't know how to make a video stop and go to the next one, but I'm going to slowly learn. I'm going to go to a next slide. OK. So I decided to do this with the idea of container schema. So a container schema, and eventually I'll learn how to make the volume go down. Yeah, it's coming out the HDMI. So a container schema is just the idea of in and out. And it's supposed to be this basic metaphor that we learn as children, that there are insides and there are outsides. There's this kind of black and white categorical boundary. And the theory by Lakoff and Johnson that we were reading about in Philosophy of the Flesh, which has been a very influential book to us, is that we learn this idea of in and out that we then apply to categories, to mathematics, to logical thinking, to computer science. What is and isn't, from experience walking in and out of rooms, putting things in and out of boxes, in and out of drawers, and that these boundaries that don't necessarily exist because it's all just molecules in space, like the water bottle example. Where what's the difference between the water bottle and the table? I don't know. On an atomic, space level, you might not be able to really tell. But when we interact with it, we know that this moves and this doesn't. The water comes with the bottle, and it's on the inside of the bottle. It only comes out if we open the container. Even though, of course, on an atomic level, all this stuff is moving back and forth, and there's no firm boundaries that exist. But functionally, with our bodies, those boundaries exist. We use them. We experience them. So yeah, I just made 50 container schema, just the idea that you put a thing in a container and now it's different, now it's in. And it's scripted very easily and quickly in this program to, it turns blue when it's in, it turns red when it's in. And just over and over and over all these container schema just to try and get at it through embodied movements and actions in lots of ways. So I eventually will learn how to stop a video without, yes?
Oh, for the volume, you can probably mute in the video itself.
Oh, that's a good idea. Yeah. And so after just containers, I wanted to look at, sorry, just what time it is. OK. So we had gone from containers to Venn diagrams. So, because that's kind of, the container schema reminded me of Venn diagrams. What if you have overlapping categories? What if you can overlap objects in the virtual world that you can't, in real life, make these intersect? Everything is separate and different, but in virtual world, if you want to, you can make things able to intersect however you want. And so this giant Venn diagram house, but I'm gonna, which we actually just showed at the Exploratorium last night. We had lots of Venn diagram stuff that was both real, with people putting them in different categories, and also virtual. But yeah, so this is the what the virtual kind of container schema Venn diagram thing was programmed in. And Evelyn can talk a bit more about that.
So a lot of those embodied virtual experiments that I was just explaining with both the container schema and then briefly showing the Venn diagram stuff was done in this really cool framework that we ended up discovering called AnyLand. It's a little bit like Minecraft. If you haven't heard of AnyLand, you go in, you just kind of make your world. It's really powerful. We've ended up doing a lot of our prototyping in there. So all of those prototypes that I just showed, they made in there. Mostly and Vi and Andrea were making a lot of them. I was kind of on the sidelines watching. And eventually, AnyLand actually lets you program a little bit within it for UCS majors. There's some scripting in there. It's a virtual world, but when you script, it looks something like this, kind of like more like conventional programming. You have like 2 fingers and a keyboard and some words, right? But really, you're in this 3D space. And I think eventually, Vi and after doing a lot of programming like this in there in AnyLand, they started just kind of seeing the disconnect. They're like, wait, well, we're in this 3D world. Why are we programming like this? And I heard that question, and it spoke to me actually because in my background, I actually worked on the Scratch project, which is a programming language for children. I was one of the lead developers on the first version of it for 7 years, and also a designer and also an educator with it. Spent a lot of time thinking about what it means to make programming slightly more embodied. It's not really embodied, right? But there's a little bit there that's a little tactile, colorful, a little less about just concepts as words and numbers, but also concepts as shapes and a little bit spatial. For those that don't know Scratch, just briefly, this is a Scratch interface. It is in 2D, it's not 3D. You get a little bit of a 2D world. This is like where all your output goes. This is your cast of characters. This is your instructions that you can choose from. And over here, you write your code. So this is what the code looks like. And again, this is what maybe one small script in Scratch looks like, and this is an event trigger that says when I receive start the game, do these things. They're color-coded. The variable stuff is all in orange, and numerical math things are in green, things like this. We were trying to get rid of syntax problems that might not be so interesting to the actual code. Why am I worried about a semicolon? That's not the thing. This was geared towards preteens, which is where like the bright colors came from. But really, kind of some powerful things about having a repeat actually be this not physical, but sort of this visual thing that just goes around code that's inside of it. So a little bit of that, just making programming the way it already worked, imperative, serial set of instructions, but making it just slightly more visual, so you might be able to, at a glance, get what a program does. I mean, and that's not new. Visual programming languages have been around for a bit. For like 50 years or so. And in addition to the imperative ones where you take instructions that are going in order and maybe give them some colors and shapes, there's also data flow programming, which is another kind of big group of visual programming languages. And this is an interface from 3D modeling software that architects use called Rhino. If you want to script, if you don't want to be putting all these boxes down, you want to like somehow script it. You can script it in Python. Python's not visual, so somebody made something called Grasshopper, which is a data flow interface for programming Rhino shapes. So this is data flow programming. It's kind of these lot of wires. It's somewhat physical. You kind of get a sense that data coming from here will go into there. Something will happen to it. It'll go into there, and so on and so forth. So a lot of visual languages, it turns out, visual programming languages, sort of fall into one of the 2 categories. There's this blog post out there that has a huge list of all the visual programming languages out there. Someone is very meticulously keeping an updated list for like the past 3 years. It's great. And I showed it to Em and Vi because I wanted them to see that many of those languages from that long list, including the one they were using themselves in AnyLand, did really fall into just one of those 2 categories. It's supposed to be visual languages that are doing something novel, but really they were either all like this, just kind of like taking serial information and putting a pink box around it. And a lot of those ideas actually did come from the same Squeak Squeak e-toys that Vi showed earlier from Alan Kay in the 70s, or their data flow. I mean, they're like, you can barely tell them apart. I don't know what all these systems are, but it's just you go down the list and they look one of the 2 ways. That's it. Except for one exception, being the actual oldest one in the list from 1963 by this is Sketchpad. It's a system, programming system called Sketchpad by Ivan Severlin in 1963. And this one stands out for me and among the rest of them because it's actual, you don't see the numbers, you don't see the words. you just see the thing, and you actually see a hand, and it's direct. There's something there, the body's involved, and there's a direct manipulation of what you're trying to program. This is a constraint system, so there is something more than just drawing. This is not Illustrator. They're actually setting up constraints that the computer can use later to constrain sides and these drawings. So it's an actual programming system, and I thought, yeah, this is kind of the direction Vi and Em started saying, well, you know, we're in AnyLand, we're in this virtual world. If we program it, why don't we just program it in 3D? Why don't we program it with our hands, with our bodies? It just makes sense. And I don't know, I think I just served as advisor, and I was like, yeah, just do it. And that's all I said, and then.
Yeah, well, that's not all you said. So when you get enough of this like history of how things have been and how people think about stuff, and just to realize that a lot of the things and ideas about computing and what computers could be and should be that existed in the 50s, 60s, 70s, a lot of those really haven't come to fruition, and some of those ideas have been iterated on many times. And it just made us think, how do we move forward? How do we get out of these ways of thinking and do things in a new way? And like, why are we so stuck? Is it a conceptual problem, or is it that it's just hard to implement? And so we wanted to start prototyping some things. So this is, I'm going to play a video of some of our first sketches into just, first step was to kind of directly copy some of these older languages into virtual reality. So this is a logo turtle that is programmed to, you know, move forward 10 steps and then turn who knows what number of degrees that is. Some number of degrees, which is right here, programmed inside the turtle. So we wake up, we put down our pen, and then 5 times we repeat this, 144 degrees to the left. And so that's kind of the first most obvious thing. Like, what if we had programming blocks that we can move in space, and we have our library of turtles, and we can grab them and put them together. This says Vi. The program looks like, it writes my name, Vi, and it looks like what it does. So that's kind of fun, although that can be harder with iterative things. So this was like kind of the first step where we're like, okay, all we're going to do is take these programming blocks and manipulate them with our hands in not the real world, but it is the real world. VR is part of the real world, I think. So we interact with it in this way and can program. But that to us is like the very first step, kind of boring. We just copied it and tried to make it a little more interactive, but still kind of based on that paradigm. And I'm going to skip ahead again. So, this is life size now, right? Now we can like walk around on our programs and kind of go along the arrows and the lines sometimes. Maybe if we have our turtle that has a loop programmed inside it, maybe we can like embody the loop and walk around and kind of follow the steps of the program. Instead of like looking at the page and going down the screen, you can have it in life size around you. And that's very easy to prototype in VR. You just make it bigger instantly. So I'm gonna move. Yes.
I can go visit that?
Yeah.
What's the name of that world?
Programmerland? Tweet me. Programo Sketch. Yeah, if you have AnyLand, and visiting AnyLand is free if you have a Vive. We have a lot of public worlds that have programming bits, including our programming public library. So we can program these behaviors using these programming blocks. This is design fiction, where secretly we have to program it in the old AnyLand way with these words, but we're pretending we're programming it with this little bit of code that says, when touched, emit bird. And then when you touch it, a bird comes out. And it should be that easy that, I have my when touched action, I add my kind of emit that quotes a bird in the hands, and then I can just attach that to anything. It's a little chunk of code that's connected to the real world that it's programming. And we realized that, the kind of copy of Scratch version would have the programming blocks be on top of each other in order, very like following the metaphor of the page. And the metaphor of the written word on the page is kind of what all computing has been based on for a long time in screens and tablets. And then we realized we could get really sculptural with it. We can arrange it in space different ways and make it like this chunkable thing in your mind where you look at it and you know what the code does because you wrote it and it's in this sculpture, and now it's a single conceptual thing instead of a collection of parts. and then you can go inside it and play with it. So those are some of those experiments. And somewhere I will be able to actually advance the slide, or I will just have to do it this way again. Someday someone will teach me how to do this. This is like a collision library, except it's a forest. And I can walk through these branching if statements that say stuff about collision. We're looking at the distance between body and an object, and then we're trying to do a collision detection algorithm, ultimately to get to these two different behaviors of when neared or when walked into, and to decide whether we're just near something or actually walking into it. This is kind of the collision algorithm going on, and all of these trees are different branching if statement trees that decide the collision. And so I can kind of take that whole collision code and plop it into whatever I want. And because I can see it's this little forest inside of my other code, like I know what the forest is even if I can't see all the details. So this idea of how to get a high-level understanding of a concept without having to read every line. So yeah, those are the turtles you saw. So we started trying to get out of just the directly translating thing and just get more towards different, more embodied and physical ideas. So here we're calling a function. The function is called dog. And we're calling regarding frog. So we call and we're asking about frog. And when it opens up its arms, we can see what the function does. And then it can hug its function back in when we just want to use it. And this is a Fibonacci kind of generator where it's iterative. It calls itself. And we kind of have this animation of how that works, but that doesn't work right now. Here's a sketch of programming neural nets where we kind of have these inputs. And you can just connect together the things in your body and with your body and see in each neuron kind of the thing it's optimizing for and how those connect together. And of course, when you import a library, you should be able to just import a library, and the library should look like a library, and it comes in on this library barge. And this code library, in fact, if you go inside, and this is public also on AnyLand, it has, these are the different kind of events you can trigger, and then we've got different actions, and some like special tools like importing or stuff like that. And so the idea, you walk into this library, there should be a help desk where you can talk to someone and they can help you, and everything should be documented and spatial. And because understanding libraries is tricky sometimes. You want to just be able to go into your library, understand what you're getting and also what you're ruining, because that can happen sometimes. So this is our library concept. And then Evelyn took that, because Evelyn is brilliant. It's like, yeah, I just kind of put the library in a library in AR.
I really wanted to see what it would feel like to have this programming language by, and then we're designing in VR out in the world with real objects too. So first thing I did was, again, those markers like I was doing with the cakes, but this time with just some of the primitives from the language. And I was in a library one day, put them in there, took a picture. Going to a library, I want this function today. Kitchen table, just bring them into my house. This is just to show that they really are kind of just these mirages on my table. But to me, they're also programming blocks. So then I just wrote like 2 tiny programs, with objects in my house. I just wanted to see what that would feel like, to have it be like play Iron Man for a minute or so, Iron Woman. And when dinner's ready. Wait, if dinner is ready, then say dinner's ready. Yeah, if the onion is hot. Yeah.
So this bringing things into the real world and seeing how they feel is kind of a process I've been learning how to bring into my practice of understanding VR. And just that, like, pretending to program and kind of, we call it human compiled programs, when we take these blocks and we're writing out programs and there's no compiler, but we know how they're supposed to run. And bugs don't exist because we're designing the language, so it needs to do what we think it should do because we're kind of designing it. And so we work in VR. That sometimes is what it looks like when we work in VR. And also this is our, or one of the versions of our virtual office. And we always want to remember what is in the real world. So even though I'm looking and like kind of interacting with virtual objects, I'm also still in the real world. And so we've been trying to get the real world to be a place where we can program instead of being stuck in front of a page. Because when we're stuck in front of a page, or by a page I mean like this, and this is how I interact with computers, and I kind of need to go there, and I'm stuck with this very linear left to right page-shaped thing. As long as we're sitting at desks, we think it's going to be harder to get to the ideas where it's natural to have things everywhere and be looking up and down. And so when we work for long hours, we don't want to be standing and running around the way you might see in like VR demos. We mostly end up sitting on the floor in various positions, and we want to have all that space available. So this is kind of our floor office.
And I'm actually remote. Most of the team is out here west, and I'm in Boston. And so we have this kind of problem of trying to bring our bodies together sometimes when I can't fly over here every day. So I am also experimenting with just programming a VR, a networked VR office that we all visit together, like the one that she just showed. And so I focus more on the software part. And this is just a screenshot showing like 2 of our avatars in a meeting. I also am interested in what it might mean to network art studios. So working in an art studio so much, it is kind of a lonely experience a lot, but there's this notion of needing other artists to come and talk to you about your work and see and mess with things and mess with your ideas so that you can move your work forward. So in addition to our networked office, I'm also building a networked art studio. This is a screenshot from a really recent experiment. I think I was, these are cakes again, different, more messy cakes this time, that I also 3D scanned. And now I'm gonna pivot a little bit to talk about what it means what experiences and what lessons I have learned from trying to, as I've been moving my art studio practice to include more VR and AR. I showed you some of the VR earlier, AR earlier. But I've also made myself a VR art studio because I just got, making art is expensive, and it's hard to have infinite materials, especially if you're trying to make physical things. And VR kind of allows you this freedom to make, objects that are free. So back in AnyLand, I've been playing a lot with the studio. With this time, it's not a scanned cake. This is one I just made out of like the 3D primitives in AnyLand, a cake slice. And I loved it because the moment I made that, I could make all these copies just immediately. It's just like, oh, because that's the impulse, right? The impulse to have like 50 or more. So I could do that, and then I could stack them and make these sculptures. And it was just so easy and it was so fun. So then because I'm in VR, I'm in AnyLand, I could make an infinite studio, and I could just make as many as I want, And as I'm walking down the studio making these, if I run out of space or I reach the edge of the studio, I just reach down and make the floor bigger and have more studio that way, or more wall space. So I have a lot of fun in there. And it lets me start doing things like make the cakes different colors, play with monochrome, which I'm interested in. I'm really interested in making, I think, abstract imagery, abstract paintings at the end of the day. So this starts letting me start sketching kind of some abstract imagery that has some tonal qualities that I'm interested in, sometimes monochromatic, sometimes not. The impulse to bring it back out into the real world with physical objects, I think first thing I did is just laser print, since you can take screenshots in AnyLand, and so then I laser print, start getting some of that nice texture back, texture from the printer, texture from the paper. You can see more of the texture there. Having done too much more with that. So then I was making those and making them into these 2D flat laser prints, which are interesting. I have a wall full of them. But then, again, couldn't help but want to see what it might feel like to have those out in the world again, in AR, even if they're digital. And I had access to a HoloLens, and just for those that don't know what a HoloLens is, a device from Microsoft, AR device from Microsoft. You put it on your head. It's a clear screen. You can see through it, and then holograms appear kind of in front of you on that little screen. They're really neat. So we had a couple on the team, and I realized that I could export as OBJs some of these things I was making in AnyLand and bring them out into the world. So this is a hologram on a table in my studio of one of those sculptures I had made in AnyLand. These are those cake slices all turned orange with like maybe a rectangle and something else there. And I put it on a table in my studio, the hologram. I had the headset on, put the hologram, it was about this big, in my studio. And then I was like, okay, I need to recreate it. I just have to make that into a real, something real with real materials. And I had just moved homes, and I didn't have much around except for like sponges and a little bit of foam and a hot glue gun. And I just got to work. The process, this is kind of a simulation. The process felt something like this. This is the hologram, sorry for the low res. And this is the sculpture I started building next to it. I was trying to make it just look similar, just intuitively. I could walk around. It was really fun. This is me, like I think I carved a piece of soap, and there's some foam and stuff there, and I was gluing where I could. And then I got somewhere. I made something that kind of looked like the thing from VR, you know? And I was so happy. It was just like, you know, I mean, I lost myself in this process. It was so much fun. It was something that felt like I was taking, you know, when I work in VR in my studio, I feel like I have this sensation that I'm somehow reaching into my mind, into my memories, and then rearranging things in there. Like I'm reaching into my memories, you know, finding some pretty difficult imagery that's hard to contend with, but then because I'm in VR and I have my body, I can contend with those memories and move them around. It's really powerful for me. And then extra powerful is then taking it out as a hologram on a table and then actually, you know, turning it into something tangible, kind of like giving birth to some jumbled memories. Just another picture, a little clearer of a thing. And at this point, you know, this again was this pretty small sculpture. The next impulse or next thing I really wanted to be able to do was say, like, okay, I need a foam budget now. We need a budget. We need lots of foam and lots of sponges. I can make, you know, 100 of these. But we did not have a foam budget. So instead, oh, these are just a couple more pictures of the object from different angles, which again, I could turn these into paintings maybe, or cover them in plaster, I'm not sure. That's the HoloLens in my studio with the hammer. So because I didn't have infinite foam yet, but I did have, and this is in my new home, my new studio is this large barn space that I hope to eventually turn into a VR, AR sculpture studio. The next thing I thought to do was, you know what, well, I've got the HoloLens, I don't have infinite foam, but I do have infinite pixels. So why don't I maybe just try making these things pretty large in my studio? So this is now just a fully digital hologram, one of those AnyLand cake things. I just put it into the barn, see what it would feel like. This is probably 8 feet tall. It's just fun to see how that feels, to have something that's so large right in front of you that came from your memories. It's kind of the feeling I'm after, I think, the sinking feeling in your stomach. There's that same little guy that I had, the hologram that I replicated in sponges, but now much bigger, and I can, you know, if you haven't interacted with the HoloLens, it's a pretty nice, easy interface, so I'm just rotating by pinching. So once I'm working large like this, I couldn't help but think, like, okay, let me go outside. Why not? And so I went, you know, visited my husband's farm in upstate New York, and had all this space, and I just put the HoloLens on and started just playing around. One of the first things I did was just like leave breadcrumbs around to see how good the tracking was and how far I could go. I went like half a mile and it still worked. It was really fun. And then I wanted to see what it would feel like to make just, you know, a 20-foot object in front of me. These are all virtual. Since again, I didn't have the materials for it, but I just made the cylinder and put it in the landscape. I'd never trained as an architect or even as a sculptor, I guess, but it was just so much fun to play architect for a second and make these kinds of artworks that, you know, you put them in the landscape somewhere and they do something to you. And so here's just like a photo of one of those large cylinders that I put. Couple more photos.
And when Evelyn showed me these, I like suddenly really understood this idea of computation everywhere, that you can just have, you know, the power of computers at your fingertips anywhere you want. And like, I knew that concept, but this is when it really clicked for me, was being like, oh, that's what it means to have computation everywhere, is running across a field, leaving breadcrumbs in real time, and like actually seeing that artwork, that was like a moment for me. Yes.
So then.
Oh yeah, I guess you guys should finish with your. Or I'll wait for the Q&A.
Okay, paper close.
Oh yeah. Do we have a timer person
I
thing?
think we're there.
Yes,
Oh.
so we need to finish by about 1:30 with the questions.
Okay.
With the questions. Okay. So I think we're like 1 minute left. Just
Okay. Yeah. Well.
yeah, so then just working out in space like that also just made me, I went back to thinking about the programs that we were making on the kitchen table in AR, and I just wanted to see what they would feel like bigger. You know, it was like a larger than life computer program. So this is a program, you know, when you touch your dog, and this is a large dog. She weighs 150 pounds, so it's very big. So that's, you know, what does it mean to program kind of at a macro scale? And this is sort of human scale, but I also went one further and just did a really quick experiment with, oh, where do you present? Here. Really quick experiment with their for loop from our VR programming language. I brought the for loop out into the Farmscape 2 and just made it extra large. This must have been like 25, 30 feet tall. And I just wanted to see what it would feel like to walk through the for loop, through a forever loop. I don't know, I'd never walked through a forever loop, so I just wanted to see. Yeah, where does a for loop take you when you walk through it? And what's on the other side?
Yeah, and
think that's
so
it.
yeah, I'm gonna just wrap up, I suppose, and that's all part of this idea of trying to get the body back into computing. So this is our workspace. This was our office in San Francisco, designed by M. Eifler, of how to work in space and office, because when you're stuck in front of this kind of flat screen, this desk metaphor, paper metaphor, you're missing, like, how do you actually live inside of your work in a way that you can just have it fundamental, like intuitive, in the sense that you're doing it all the time. You're not designing this stuff from flat. You're working in an office where you're sitting on the floor, on cushions, crawling around, and that's just your everyday workspace. And how can you program like that? And how can you do art like that? How can you think and feel and see in new ways? Okay, thank you.
So I really like your 3D programming art. You've really solved the problem of getting programmers to exercise. I'm wondering how things like refactoring work in this context, right? Because like a lot of programming is just like copy pasting text and like doing find and replaces, right? Like a workflow, like getting stuff from Stack Overflow involves a lot of that. Like how would that kind of thing work in that environment?
My immediate reaction is to think of a screenshot that Vi did not show, where she talked about it, but she didn't quite show, where she had the same program written 10 different ways, which were 10 sculptures. And I saw that as different refactorings of the same thing, in a way. But I guess, I mean, I don't want to speak for you, but my sense was that, so this is one of the refactorings of that program she showed earlier. And if you were to turn this into a different sculpture, like what would your process be, I think is what he's asking. Like maybe you'd shrink it and...
Yeah, maybe. The interesting thing about when we have this whole world of programs is that suddenly it's really easy to find things. Like if I want to find this particular bit of code, I know exactly where it is because it has like a sculptural identity. And so when you're talking about refactoring programs, or you have this whole mess of text and you want to find and replace, or even just change the value of one variable, right now, programs have very little texture, and you're kind of scrolling through, trying to find the right indents for the thing. And it's horrible. Whereas here, I suddenly realized how horrible that way is, because it's so easy to just go in the world and I know exactly where any part of my program is. So hopefully that will help people be able to switch out and in parts and change the design when you can hold it all in your head in a more spatial way. Yes?
Yeah, so I really liked the talk. Like, thought it was really amazing. Had all sorts of cool ideas. I was curious about your use of metaphors. It seems like a lot of what you do is trying to like evaluate different metaphors. Like, what does this metaphor mean? How does it work? And like reminded me of like another Lakoff book, The Metaphors We Live By.
Yes.
Which is also, I mean, reminded me a lot of like how do you know when it's a metaphor? Like, how does it influence you? I was curious like when you felt that the metaphor was more successful or less successful. For example, like one thing that your talk reminded me of was like, what happens if a program crashes? Now I have to think of like, what is the creative, space of like what a crash looks like.
Yeah, and crash itself being a metaphor.
Yeah, maybe like everything falls down or it breaks apart or something. But like, when do you, I guess, how do you think through that?
Yeah, so we didn't show too much of the Venn diagram project, although we've written about it a lot on our website. And that was something where I started to feel like the metaphor was working, as an example. So in this, we had different objects. So we had this set of kitchen drawers. And one of those ideas and metaphors we live by, or philosophy in the flesh, is that the container of the drawer in your kitchen teaches you what categories are and how you categorize things. And so I made a set of drawers that was 2 overlapping drawers, and you could open one or the other or both, and there's a space. There was like a fork drawer and a spoon drawer, and if you opened both at once, you got spork drawer, exactly. And so when I started really immersing myself in making 50 Venn diagrams, and then even more than 50, I just kind of Venn diagrammed my heart out. You start seeing them everywhere, because once you get that in your body, now there was more and more that I was seeing, and that's an example of, I think, a successful metaphor where I think if everyone could play with more overlaps in their mind, with their bodies in VR, where it's physically possible to intersect things, then we would also be able to have more intersectionality at the tip of our brain in real life, instead of it being kind of difficult to think about and needing extra help to think about. One more? Yes?
Great, wonderful presentation. I think it was extremely inspiring. I wonder if you guys talked a lot in the presentation about different visual programming techniques or languages or styles. And I wonder, it seems like so much of what you're talking about really connects with kind of programming by demonstration, or at least in terms of how you were showing different motions or different things like that. And I'm wondering if you could talk at all about how you think, what parts of some of the languages that you created you think could be done by demonstration versus some parts that it seems like it would be hard to map that to demonstration.
Evelyn, given your experience in demonstrating and helping people learn Scratch, I think this is a good question for you.
When you say programming by demonstrating, you mean what again?
So for example, in the case, so programming by demonstration is one technique of programming where you can essentially record what you want to do and then be able to play that back. And so in the case of where you have the hand that points to where something is touched and then a bird comes out of that, I could see that being really directly mapped to like someone being able to demonstrate, oh, I touched this, and then a bird comes out of it, and then that could be captured in some representation. But then some of your other kind of more procedurally oriented things might be harder to do. And so I was wondering if you thought at all about connecting sort of the motion that you were trying to show in terms of the earlier work that you showed, in terms of showing acceleration and other things, and then connecting that with the directness of the programming.
Something that makes me think of is some work we didn't show by that having to do with scales of abstraction in interfaces, which maybe is getting a little bit at what you're asking. What you're asking could be a whole talk, I think, about programming language design. And to answer that first, I guess I would just say we haven't played enough, and I think I was waiting for us to just get all the different parts out there and then think about how to connect them, and that's probably where we would move next, is to think about what you're thinking, what you're saying. But then Em has done some work sort of along those lines that I think I could connect into the programming stuff. In VR, Em has designed what they're calling different scales of interface, meaning they made a podcast app in VR. And they have three different scales for it. One is wearable, so it's in my ear. I'm wearing it. The podcast app, I'm wearing it. If I want to play it, I just touch my ear. That's one scale. It's the wearable scale. The next one is holdable. Then I just take off my earring, podcast app, and hold it. It kind of inflates a little bit, and I see more detail. And then I can interact with it a little more. I can rearrange the playlist, or I can move things around. And then the next scale is to press maybe something in the holdable one, and it inflates even more into the size of a room. And now I'm walking through my podcast app, and I can feel it, I can see it, I can see more detail. And the programming by demonstration stuff and how it relates to kind of the more, the other kind of programming, I think could benefit from a similar kind of scale shift, or a kind of, like you have someone come in and say, yeah, I want that when the bottle falls like this, it makes a splash sound, and that's my demonstration. And then to go in there, maybe I click on something in the interface, and then I'm at the level of the code, and there's another embodied way to think about the coding. So I don't know if that makes sense. Does that?
So Ken Perlin's work at NYU actually is also Chalk Talk is kind of this programming-ish language community. I don't know what you would actually call it, but that does have some. So from the world of animation, it's often in animation. There's things where like, oh, I want to just show the animation software what path the thing takes by drawing the path, and then it'll animate along the path. So yeah, the most relevant work to VR and programming, I think, is Ken's work. That kind of takes some of those animation techniques into programming languages using drawing, and there's some of that, some aspects of that. So yeah, we'd love to bring more of that in.
All right, let's thank our speakers one more time.